Hi everybody, if you'd like to hear a proficient read through, I'm going to read through the first reading, so you can follow along with me here. Conservation of energy in chemistry. We have already studied the law of conservation of mass, which states that no mass can be created or destroyed in a chemical reaction. Energy is also conserved in chemical reactions. Energy is the capacity for doing work or supplying heat. The first law of thermodynamics, often called the law of conservation of energy, states that the total amount of energy in an isolated system is constant. Energy can transfer from one type to another, but cannot be created or destroyed. Although we often say that reactions can create or absorb heat, what we are really seeing is a transfer between two different types of energy. Potential energy is energy that something has due to its position. In physics, a roller coaster at the top of a hill has a lot of potential energy from gravity, whereas a drawn bow has potential energy from stretching the bow. In chemistry, potential energy is energy locked inside of the bonds of molecules because of the position of the electrons and nucleus. And in this diagram, you can see an example of potential energy. It's related to the position of atoms and electrons. If they're bonded, they have low potential energy. If they're far apart and they haven't bonded yet, then they have high potential energy. And when they do bond, they release that energy. When chemists discuss kinetic energy, they're actually talking about the energy that comes from particle motion. Since the motion of particles can also be measured as temperature, kinetic energy in chemistry is sometimes simplified as thermal energy. Chemical reactions can transfer potential energy to kinetic energy. That would be exothermic. They're releasing kinetic energy, so it's releasing temperature. Or kinetic energy to potential energy. That'd be endothermic. We studied that in Unit 4. Since kinetic energy is easily observed and potential energy is not, it is important to remember that any new kinetic energy must be coming from potential energy to obey the first law of thermodynamics, conservation of energy. If a reaction occurs and releases heat, kinetic energy comes out, that means that it must be losing potential energy. This is why exothermic reactions are said to lose energy, technically potential energy, even though they get hotter, which is an increase in kinetic energy. And in this diagram, you can see that the total energy is the same. In this exothermic reaction, the green from the very beginning to very end is lower, which means more kinetic energy. So it's lost energy in the sense that it's lost potential energy, although technically the total energy is the same. Last paragraph. Conduction occurs when two objects at different temperatures are in contact with each other. Heat flows from the warmer to the cooler object until they're both at the same temperature. Conduction is the movement of heat through a substance by the collision of molecules. At the place where the two objects touch, the faster moving molecules of the warmer object collide with the slower moving molecules of the cooler object. As they collide, the faster molecules give up some of their energy to the slower molecules. The slower molecules gain more thermal energy and collide with other molecules in the cooler object. This process continues until heat energy from the warmer object spreads throughout the cooler object. Some substances conduct heat more easily than others. Solids are better conductors than liquids, and liquids are better conductors than gases. Metals are very good conductors of heat, while air is a very poor conductor of heat. You experience heat transfer by conduction whenever you touch something that is hotter or colder than your skin. For example, when you wash your hands in warm or cold water.